techniques related to radius is radius COA, which I'll talk about a bit later, which means change of authorization, which is RFC 3560. Anyway, you guys saw it. Which is, so the COA answers the problem of doing, because radius is initiated by the switch and the client, the COA takes care of the server says to the switch, please rethink the security posture of this device. And so it's kind of adding a new asynchronous nature to the usually really synchronous nature of radius. Never bring your friends to your talk. All right. So what do we do for the enforcement then? We accept most requests. And then based on that acceptance, we return the proper VLAN attribute on clients. When someone is not known to the system or is not authenticated, we return a registration VLAN, so a VLAN where we present a captive portal, or if the user should be in isolation stage, we return the isolation VLAN. And so that's how the magic does. So we do accept most requests. Otherwise, the user will not have network access, which is kind of defeats the purpose. We use FreeRadius to do the radius and .1x pieces, and it's great. Complicated to configure, but it's great. It works well. Now, what we added is a Perl module to the FreeRadius. FreeRadius has this RLM Perl facility, which allow us to use Perl code directly into the FreeRadius. It's very performant, and with that, we do a SOAP request to the PacketFence daemon, if you want, to the Apache of PacketFence. And the decision is taken server-side. So this allows for a nice architecture that I'll talk about later. Now, moving on to the captive portal. Various authentication mechanisms. So we support LDAP, AD, Radius, Kerberos, and guests. We use the portal to do the authentication. If a user did 802.1x, then the authentication already went to the AD server. So we don't need to present the captive portal. So it's there's a lot of options there actually if you want to automatically register devices and stuff. What does the captive portal do after someone's authenticated over HTTPS strongly is we redirect them to the internet. And we can also provide remediation information, which we'll see later. In order to reach the captive portal, on the VLANs where we present the captive portal, we provide the HTTP. And then in the HTTP, we provide the DNS server, and we do a DNS black hole. So any request will get the same answer, which is the PacketFence server. It's really simple, cheap technique that we do. And then with the first hit on the browser, we use mod rewrite to rewrite the URL. For example, google.com will be rewritten to pf.initech.com/captive portal, which allow us to have a valid certificate because we have a domain name there. So it's not like other solutions which are doing reverse proxying, which then you have SSL problems with that. So it's I'm kind of glad that we did that. So how do we do our voice over IP now? Our old technique, because we're kind of changing this right now, is we rely on CDP and the voice VLAN features of the switches, which is actually easy to attack if you want. So now what we do is we handle them as regular devices, and we try to automatically register them if the user wants that. But there's still the older technique, and CDP is so transparent that a lot of people prefer that, even if it's insecure. Over radius, we do MAC authentication, and then your phone doesn't really matter. What matters more is your network device, so the switch in question. And with 802.1x, there are some vendor-specific attributes in radius to control the behavior of the VoIP stuff. But we've never saw a lot of 802.1x capable phones, so it's really a tricky business, and we've done it over wireless and wired, but it's not. I think we only got it with Avaya so far, and there's not a lot of customer demand for it, and because there's not a lot of phone who does 802.1x, so it's getting there. Maybe I'll have another presentation on that.
How do you handle devices downstream from the phone?
The PC behind the phone, voice over IP. Yeah, this is exactly what I mean by voice over IP, is that if it's only a phone, then I don't really care. I am handling it like a normal device. But if there's a PC behind, then there are problems with that, especially because we provide DHCP. You know, I'm seeing the time flying, and I really want a question about it in the debriefing, and I'll give you all the details. It is tricky business. When it's over radius-based technique, it's easier and it works better than when it's over SNMP-based techniques, because of the influence of changing the primary VLAN ID on the port and stuff like that. You really need to be careful and tag the proper voice VLAN and stuff. So yeah, I want to talk about this later. So, for the voice over IP, a little note to pen testers: most want auto registration of the phone. The phone doesn't have a browser, so you cannot ask your user to go on the phone and register it. So either they have a list of all the MAC addresses and they automatically register them, or they do it through several techniques, which is MAC vendor prefix. I saw that. I think the 3COM switches do that, which is really discutable, which is a really tricky, or I think insecure technique if you want. Others do it through CDP. We, PacketFence, do it a lot with DHCP fingerprints, which are something I talked about yesterday about the finger bank project, which is really rarely spoofed so far. But as more people will gain awareness that we're doing DHCP fingerprints, I'm pretty sure it will get spoofed, and then people will get access to the LAN by spoofing a DHCP fingerprint of a phone. And also, the phones that are 802.1x capable are doing MD5 authentication, which is a flawed EAP technique for 802.1x. So it's not great. And so the note is here: spoof any of these techniques, and you'll get access to the voice VLAN. And then from that, scan and try to pivot, maybe if you can, on the media server. So pen testers, you should really look into the voice VLAN stuff. So quarantine is the captive portal feature where we present remediation information to the user. Here's a screenshot of how it's done. Now, I made that up. It's not a real technique that we have. It's written here: you have been detected using Windows 95. Please install a decent operating system. Download OpenBSD. That will probably not work on a desktop computer, but I don't want to get a flame started. So the triggers we have for quarantine is operating system based on our DHCP fingerprint, browser, Mac vendor, Nessus, IDS, which is snort-based, which I'm going to talk about in the next slides. And so the captive portal provides instruction. It's really helpful to reduce help desk pressure when you implement NAC. And so we've been really enjoying doing stuff with that, and it's the customer who come up with the greatest stuff to do with the quarantines, and we really like that. So the policy checking and monitoring, how the Nessus side is client-side scanning upon authentication. It's, I say, somewhat limited, because if you don't provide a domain, for example, domain credential on the Nessus scanner, then you can only see the surface exposed on the client. So you can prevent them from running a web server, for instance, but you cannot do more. But if you do provide domain admin credentials, then you can, hit on the device and then list the patches and stuff like that. It's not free, and also the more tests you have, the longer it will take to authenticate, to authorize a device on the network. And it's something that a lot of people, it takes 2 minutes to do an Nessus scan on the client, it's too long, so let's forget about that. So it's been mixed love-hate relationship with our Nessus implementation. Then the snort piece is more, most of you guys know snort, I'm pretty sure. And so it's an intrusion detection system. You clone your traffic that is going to the internet, to the PacketFence server. You run a local snort instance there, and you enable the rules you're interested into, and the devices violating the rules will be isolated. It works really, really great, and we've been doing a lot of BitTorrent blocking, Skype blocking, malware detection, preventing users from nmapping the servers and stuff like that, and it's great. And with the quarantine captive portal, we are able to provide a couple of like you can do BitTorrent 3 times. After that, you are completely locked out of the network. So each time we present you with the captive portal, but you have a button to re-enable your access to the network. So you can do stuff to annoy your users if you want, like allow them to re-enable their internet access 100 times or 1,000 times and see how long they will, you know, try again and try again and try again to do peer-to-peer before they are getting tired and just calling help desk. What's going on? No, we don't do that, and it's probably because we were never asked this. Come up over for a beer. So, again, being open source, we're really and running a business on open source, we're really tied to what's going on the. Here we go. Oh. I'm sorry. So yeah, we're always interested, and the syslog stuff, there are new switches that can send syslog events, and I saw the features and I never looked into it, but it would be something really interesting.
Why not log in or even connect to the database of another storage server that does see the traffic?
We do support that. We have a remote mode for Snort, which we use our own daemon, we tail the alert file, and then we do SOAP requests. So then you avoid crashing your whole PacketFence because there is a gigabit of traffic per second to analyze for Snort. But Snort, with his single-threaded approach, has been quite good because it cannot crush the rest of the system because it's only using one core, one thread. So it's still interesting, and we have a really big enterprise customer running Snort and PacketFence on the same server, and it's doing great. So how do we support network access? I see that I will run out of time. I need to move faster. Adding a new supported switch for the radius-based technique is really great. All we need to do is, because all the legwork is done by FreeRadius, all we say is we support wired .1x, and if the NAS port that is sent by the switch is the same as the EF index, there's nothing else to do. And then we implement deauthentication, which is, again, very standardized. There's the PAE reauthenticate SNMP MIB that works in like 99% of the cases. And so for us, adding new radius-based supported device is really easy. SNMP is more challenging because it's not standardized as much, especially regarding port security. A lot of the hardware do it per switch port VLAN, and some of them do it per switch port. And so because of that, there are different tricks that we need to do, especially with voice over IP again. So it's a love-hate relationship, and it's one of the things that brings us customers, and we work on supporting new hardware, and they pay us to do so. So it's been good for the business, but for your mental health, it's not that great. It's like there's nasty bugs in there. I'm going to talk about it a little later. But it's mostly read the switch documentation, try to configure it, figure out that there are mismatch between the documentation and how you actually configure it. And then you SNMP walk and you try to find the sexy stuff you're looking for, the MAC addresses, port security information. And then you do your SNMP set, and then when you got it working with SNMP set, then you port it into your Perl code, and then rinse, repeat, and you have a switch working with SNMP.
Are you working with all 3 versions of SNMP?
Yes, we are, but this is a NetSNMP library which encapsulates all of